So in 9.4, we're going to take a look at perimeter and area within our coordinate plane. And specifically, we're going to talk about the area and perimeter of irregular shapes. Now in 9.3, you use composite figures to go ahead and help you find the area of irregular shapes. Another way in which we're going to find area is to actually estimate that for our irregular shapes by using squares within a grid to help us count the area off. It'll make more sense when we get to this next example. So here's an example of a problem in which I would ask you to estimate the area of an irregular shape. Now this shape is not a triangle or a rectangle or any of those nice geometric figures we've dealt with before. What we're going to do with this though is we're still going to be able to estimate the area of the shape by counting up how many squares it has inside of it. So for every full square it has inside of it, that's going to be 1 square unit. For every somewhat half of a square, we'll count that as a half of a square unit. For stuff like this up top, I'm not even going to bother with it. So why don't you go ahead, take a look at this problem, try to count up as many full squares of area that you possibly can, along with as many half squares. Add them all up and we'll see if you and I end up getting the same estimate for our areas. Alright, so taking a look at this, I ended up putting in full squares for every time I saw that my area covered majority of the square. And then for instances where I had it not covering exactly majority, but about half of it, I put a half square in there. So when I counted up all my full squares, I ended up getting 26 full squares, so that would be 26 units squared. And then I counted up all of my half squares, so I ended up getting 11 half squares. And 11 half squares would have 5.5 units squared. So when I did this and I added about, you'd probably get about 31 square units or about 32 square units. When you did it, you might get 30 square units. As long as we're within a couple square units of each other, we're okay. Same concept. How about you go ahead, try to estimate the area of this irregular shape by doing exactly what we did in the previous example. Pause the video, do it on your own, and then when you're set and ready, come back and I'll have my answer written for you. Alright, so taking a look here, I filled my diagram in with squares and half squares and counted them all up, and I ended up getting 33 full squares and 9 half squares. And when I add the values up together, because 9 half squares would be about 4.5 square units, adding those two together, we get about 38 square units. So if you got anywhere from like 37 or 39 or even 36 once in a while, you're good. Now, just a refresher before we move on with our next concept, we want to remind you that if you're working with 2 points, x1, y1, and x2, y2, the distance between those 2 points is given by our distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And then also, if you have to look at the slope, taking a look at the slope, your slope formula between those 2 points is always a y2 minus y1 over x2 minus x1. So the reason why we took a look at distance formula and slope formula is because if we take a look at this example, we're going to ask you to draw and classify the polygon with these specific vertices. And luckily for you, I already have that drawn here for you. What we want to do is we want to find the perimeter and the area of this given polygon. So first off, if we draw this out, which it is drawn for you, and we want to classify the polygon, we have to decide what kind of polygon is this. Well, I know it's a quadrilateral because it has 4 sides. However, what kind of quadrilateral is it? If I take a look, I know it's not a square. I know all of that, but I can specifically state from, if you find the slopes of each of these segments, which you can do on your own, okay, this would be a negative 1/3, so would this one over here for HG, and then the slope from G to F, if I'm counting up, it's up 2, right 3, so that would be 2/3, and the slope from HE is also 2/3. I have both pairs of opposite sides are parallel to each other, and that is a parallelogram. So classifying this, this is a parallelogram. Now, the next thing we have to do is we have to find the perimeter and the area of the polygon. So the perimeter means I'm going to have to find out what the length of each of these segments is. So off to the side, what I would like for you to do is I would like for you to figure out what is the length of EF That'll actually be the same distance from H to G because it's a parallelogram, opposite sides are congruent. And the length of GF would be corresponding to the length of EH. So you really only have to find the distance of two of them in this case. Why don't you go ahead and do that off to the side. I'll do it on my own, and when you're all set and ready, start the video up again, and I'll have my answers written down. So now that we found out what our distances were for EF, we know then that HG would also be the square root of 10, and the distance for GF is going to be the square root of 13, just using my distance formula. That's all we were doing. So to find the perimeter, our perimeter is where I would take, in a parallelogram, you take 2 times one of the sides. So I've got 2 of the square roots of 10, and I've got 2 of the square roots of 13. That's going to be my perimeter. Now, if I'm done with my perimeter, because that tells me how much I have going on around the figure, I want to find out what the area of the polygon is. Now, we know area of a polygon, or a parallelogram, is actually going to be base times height. The problem with this is it's hard to figure out what the height of this parallelogram would be, so it's just easier for us to do this. If we take a look, let me go ahead and get rid of some of that information. Actually, I want the P left there. Okay, the easiest way to do this is just to build a rectangle around my figure, and we're going to use a composition of figures. So if I build a rectangle around the figure, and then after I'm done building the rectangle around my figure, I go through and I find out what the area of the entire rectangle is. Find the area of this entire rectangle in here, okay? Then I can go ahead and I would subtract off then the area of each and every one of the triangles on the sides, okay? So when I do that, that will then leave me with the area of our inner parallelogram. So let me do that again. Let me just go ahead, draw the rectangle around. We're going to find the area of the rectangle, and then we're going to subtract off the area of the triangles, thus leaving us with the area of the parallelogram on the inside. So let's go ahead. Area of our rectangle here. Well, it's got 1, 2, 3, 4, 5, 6. So it's 6 units this way, and it's 1, 2, 3 units this way. So the area of the rectangle is going to be 6 times 3. From that area for the whole entire rectangle, we're going to subtract off the area of the triangle. So let's start off with this triangle right here. So this triangle right here, the area of a triangle is 1/2 base times height. So I would have 1/2 my base. The base of this triangle is 1, 2, 3 units. The height of this triangle is 2 units. Now, do you realize that that triangle and this triangle are the same? So I really have 2 of the same triangles, and when I find the area of those triangles, it's 1/2 base of 3, height of 2. Then I'm going to subtract off, so that would take care of the area of those 2 triangles. Then we're going to subtract off the area of the other corner triangles, so these 2 triangles here. And when I look at this, those 2 triangles have 1, 2, 3 for the base and 1 for the height. So I would say we're going to subtract off 2 of the triangles that have 1/2 base of 3, height of 1. So that would actually take care of this bottom triangle also. Notice then all I'm left with is all of this area on the inside. So it's just a simplification from here. So I have 18 minus this 2 and this half cancel, leaving me with a 6 for the 3 times 2, minus this 2 and this half cancel, leaving me a 3 for the other 2 triangles. So 18 minus 6 is 12, minus 3 ends up giving me 9, and its area, so we're going to say it's units squared. All right, so in this last example, we're going to do exactly what we did before. Pardon the having to write all of this out up here, sorry. Just realized that we had a typo in here, and I'll have to take care of that later. So I end up having the points K, L, H, and J, and they're all vertices on this polygon. Now once we've got that, we're going to classify the polygon, you're going to find the perimeter, and you're going to find the area of the polygon, just like what we did before in the previous example. You're going to pause the video here, do that work on your own, and then when you come back, I'm going to have all of my answers written out for you, and then we'll double check. All right, so the first thing we had to do was classify our parallelogram. Now our parallelogram here, if I look at the side HL and the side JK, they both have the same exact slopes. They're both vertical line segments, so they're both slopes are undefined. Then looking at HJ and LK, both of those end up having a slope of 2/5. So we ended up having both pairs of opposite sides that were parallel, meaning it's a parallelogram. Next thing after classifying our polygon, we're going to do is we're going to find the lengths of the sides. So JK and HL, pretty easy to find. They're vertical segments, so I could just count out the units, and I ended up getting 5 units for both of them. The next thing I ended up doing was finding out the distance for HJ. As soon as I found out the distance for HJ, I noticed that it was the same distance for LK. HJ, using my distance formula, ended up being the square root of 29 units. So the perimeter was just adding up all the sides. So I had 2 of them that were 5 units and 2 of them that square root of 29 units. So my total perimeter was 10 plus 2 square roots of 29 units. Now in this problem, it's slightly different than the last one we did. Finding the area in this one is actually pretty nice because the polygon that we're working with, which is a parallelogram, the base, we're going to say this is my base, okay? If you kind of tilt your head or take your sheet of paper and rotate it, make HL your base, you're going to end up noticing that your base is 5 units, and the height of this will actually be the distance that is perpendicular to my base. So if I look at it this way, if my base is HL, then my height of my parallelogram is going to be that right there because it's perpendicular to my base. So if I count out the units then, for this one I get 1, 2, 3, 4, 5. I end up getting 5 units for my height for my parallelogram. So my base is 5, my height is 5, that's why it's base times height, is 25 units squared. Now if you did the other one like we did before where you drew the rectangle out and then you found the areas of the 2 triangles and subtracted them, fantastic, that would work also. You would still end up getting the same exact answer of 25 units squared. So that's it for this lesson. Make sure that if you have any questions, write them down, ask them in class, and then make sure that when you're going through the homework in class, though, too, that you're asking questions there, because we need you to make sure that you understand what's going on. Any questions, ask them, ask them, ask them. Otherwise, have a great night.